Hello everybody, welcome to Marketing Analytics course. I am Dr. Shagata Chatterjee from VGSOM IIT Kharagpur who is taking this course for you. We are in week 10 session 5 and I will discuss about how to use R programming to apply the naive-Bayes algorithm in a data set. The data set is given to you, it is the SMS spam data. So, we will first put the set working directory and then I will read the data. The data set looks like this, where if you see it carefully, there are the type whether it is spam or ham and the text is written. For example, complimentary 4-star Ibiza holiday blah blah blah, this is spam, but are you this much busy or please ask mommy to call father, this is ham. So, we will be playing with that to see the whether. So, I read the data first and then I put the names properly. The structure of the data looks like this. There are 3 columns, serial number, the type which is factor variable, spam and ham, there are 2 factors, and then the text. And then what we do is, if I just check the table that there are 4812 spams. So, to get an idea, there are 4812 divided by 5559, that means around 86% ham and then 14% spam, or 86.5% ham and 13.5% ham is there. Fair enough. So, now as usual library TM we are calling it, changing it to corpus, we have done this before, and then I will print the corpus, at least the print the corpus says that it has a corpus specific 1, document level 0 and their documents are 5559, and if I inspect the first 10 documents it looks like this, which is basically the first 10 observations. Now, with this what I do is I transform it to the lower, I remove the numbers, I remove the stop words, I remove punctuation. We have done this before, right, in session 2 if you are not wrong, session 2 or 3 I have done this. So, strip white space, so we are removing this, and now with this thing I am creating a document term matrix. So, SMS DTM is a large matrix. Now, next what I am doing here is there are some purpose of doing this. So, there are 3 things you check. There is a raw data, from there we created the corpus, we cleaned the corpus and created data document term matrix. Now, I will break this raw data into training raw and testing raw. Training corpus the same, exactly same row numbers, training corpus and testing corpus, and training DTM and testing DTM. This is something that I am going to create. Why? Because some of this raw one will be used to create word cloud, corpus might be used to create something else, DTM might be used to create something else. So, there is certain purpose, but there should be some matching. So, that you see these 3 guys should be related to each other and these 3 guys should be related to each other. So, I am using the same column numbers, row numbers 1 to 4169 and 4170 to 5599. So, I am just, so if I just do it 4169 divided by 5559, that means around 75% goes to my train and 25% goes to my test. So, I am breaking this thing. So, the first one is the raw data, next is DTM and third is corpus. Fair enough, I have broken them. Why I have broken them? So, after breaking them I want to just see that whether I have not done randomness. See, so I am just checking that whether even the training and testing data I would say distribution of spams and hams are similar or not. If you remember earlier it was 86.5% ham, in the training data it is 86.47 similar, here it is 86.8 more or less similar. So, I can deal with this thing. So, now with this data set what I do is next is I call the library is word cloud, I am calling the library, and with the corpus I am trying to draw a. So, you see this is the corpus of my training data. This is how a word cloud looks like. This is a word cloud, this is how exactly it looks like. So, word cloud I want, let us say these guys, the bigger one, the bigger the words are in the word cloud, the more frequency of that word is there. Now, if I just random order is equal to false, if I do that what that will do. So, before you plot the next plot, it is better to clean this plotting area. So, what it will do is it will put the important ones at the middle. So, you see call, now, just, will, can, these are the. Now, what is my purpose? My purpose is using words to analyze whether it is spam or ham. So, by that logic, exploratorily or visually, if I see that the words which are coming common in spam and the words which are coming common in ham, if that words are different, in other words, the word cloud of a spam message and word cloud of all the ham message, if the prominent words are different, then only I can say that words are a important variable to predict whether it is spam or ham. Understand carefully what I am saying once more. I am saying that I can use words as my predicting variable for spam or ham only when the word cloud is giving me different sets of words for spam or ham. That is the only case. So, what I do next is I divide the data set into spam and ham. Okay. So, subset the raw data into spam and ham, and now with once I will draw it with spam and then I will draw it with ham. So, I have drawn it with spam. Okay. So, let me draw it once more, it did not come properly. So, I will draw it with spam, and spammy, if you see carefully, the words that are coming up call, free, now, mobile. So, some words, just remember the claim, just remember these words, and for ham the words that are coming up are just, will, don't, can. So, call and now are same, but claim or let us say mobile, these words are going away. So, there is some difference between the words that are common. So, that suggests that words can be one variable to use that. I have also shown how to create very beautiful word clouds which can be used for your reporting purpose. Now, imagine how many words are there. So, if I just find frequent words and then put it 1 here, it will find out all those words which has a frequency of at least 1. And there are 5738 words are there, unique words are there. So, sorry, not 6000, so thousands are printed and omitted are 5738. So, total 6738 words are there. There is no point on playing with so many words. If they are occurring only once, why will I have an importance on them? So, what I do is, I find out only those words which have up to 5 frequency, and those words are 1216, 1216 words. So, what I do next is put these words in a dictionary and then again create this document from matrix training and testing, whichever I have created here, this document from matrix DTM training and testing. I am recreating them, but now with a dictionary of this data, not the whole set of words. So, I am creating a document term matrix. If you remember, document term matrix was the terms in one side, the document numbers and their corresponding counts. Okay, not whether it occurred or not. How many times it occurred was there. Now, remember, in my naive Bayes algorithm, when I taught naive Bayes algorithm, it was just telling Viagra was there or not, yes or no. Grocery was there or not, yes or no. Unsubscribed word was there or not, yes or no. It was not talking about whether that word is occurring 5 times in a particular row or 2 times in a particular row. The frequency was not there. The only thing that was a variable was the occurrence, whether it occurred or not. So, I have to also do something to change this document term matrix, which is frequency oriented, to a occurrence oriented. So, I am creating a function called convert counts, which takes a value of x. If the x's value is greater than 0, any positive value, it will make it 1, otherwise 0. And then 0 and 1, it is labeling at as no and yes. So, that is how I am writing a function, and then I will use this function on my training and testing DTM, document term matrix, to convert them to this kind of a thing. So, if I just run this, it will take a little bit time. If I just run this one and convert them to yes no basically instead of the counts, the training one has been done, the testing one has also been done. The summary of the training one looks like this. So, these are the word, first 5 words, first 5 randomly chosen. No, it is not like the first 5 were based on the frequency or something. So, this word is occurring, not occurring for 162 times, occurring 7 times. Good is occurring 163 times and not occurring 4067 times, and so on. So, that is how I have created the summary. Now, what will I do? I will run an if base now. The library is E1071. There is no such package. So, I have to install the package. So, E1071 is the package name. I am installing it. Okay, it has been installed. I am calling the library now. It has been called. There is a warning sign. We'll don't care the warning sign probably. And the function is naive base, where the DTM is my x variable and the y variable is the SMS raw train, the raw data, raw training data's type variable is my basically the y variable. So, now if I just run this thing naive base, it will take some time to train. It is training right now. It will take some time. Okay, it has trained. And if I just want to see the tables, so the first 2 tables, it will create. If there are 4 words, if you remember, there were 4 tables. For Viagra word, there was 1 table. When there was Viagra, unsubscribed, grocery, and so money, there were 4 tables. Here I have taken 1 to 16 words, top words which has at least 5 frequency. So, there will be 1 to 16 these things, and I have taken only first 2. You can choose which word you want to choose. So, if you see carefully that when there is ham, given it is ham, the probability of checking occurring is 0.99 and checking occurring is 0.002 and checking not occurring is 0.998. And given it is spam, it's always it is 0 and it is 1. Similarly, given it is spam, the probability of it is a numerator. So, P of m given S, remember. So, given it is spam, the probability of this occurring is 0.1 and 0.98. So, there is some distance here 0.01 and 0.04, some distance here, but there is probably very low distance here in the 0.000 and 0.002. So, we have to check for different kinds. So, if you remember, there was a word called mobile, or there was a word called claim. So, let us find out where the word this thing is. Okay, so, I will just quickly find out the position of the word called claim. So, how will I find out that? So, find frequent terms or SMS dict. So, claim, GREP function is written like this, GREP. So, the help will tell me that how, pattern and then X. Okay. So, GREP, then the pattern is claim, and what I am searching, SMS underscore dict. So, if it is 187, okay, So, 187 and 566. So, if I just check 566 what? 566 is claim to claim. So, that is not so important word, but 187 is the word called claim. So, I will just check this particular table whatever I created for 187, word number 187. Let us see, and then you will understand why I am saying this. So, if I just write 187, this is the claim word, summary of SMS train C187. Oh no, so not sorry, no, sorry, not summary, this one, not summary, this one. And if I just write 187 here, you see that for claim, when it is spam, the probability is 0.5 that the claim word will be there, ham is 0.84, and when it is ham, the probability is 0 and 1. So, there is a huge distance, 0.00 and 0.55, 15% distance is a very high distance. So, that is something that we are trying to find out here. So, now based on this, I will predict with my SMS test as my testing data, I will predict, and then in the testing data we will try to see that whether prediction is working well or not. So, let it predict a little bit, it might take probably another 1 minute time. So, we are handling pretty large data set, 5000 data set. Even if it is taking 30 second, 40 second, that is okay, good enough to deal with. So, let it predict. So, right now it is predicting for the testing data only, and SMS test is around 1390 observations, but there are 1216 variables that are there. So, based on that it is predicting. Yes, the predictions has been done, and now if I just plot them. Okay, so, G models package is not there. I will quickly do G models. Install the package. Now, if I run this, you see out of 1390 observations, I am correct 1203 times and 151 times. So, 1203 plus 151 comes up to be how much? 1354. So, 1354 divided by 1390, I am correct almost 97% times on this data set. Okay. And then if I just think about spam detection, there was, this is actual, this is predicted. So, actually there was spam 183 and I am correctly predicting 151 out of them. So, 151 divided by 183, I am also correct 82% times in the spam detection part. So, more correct in the ham detection part, less correct in the spam detection part, but still it is giving pretty good result. So, that is how we can use naive Bayes algorithm in spam detection. So, that is all for this particular video. In the next video or probably in the next week, we will use all whatever we have learned in further more advanced application like sentiment mining and emotion mining to find out newer insights. So, thank you very much for being with me in this particular video, and I will see you in the next week. Thank you.